Alright, so now we can move ahead to the second question, which is that we are provided with these tier ratings, which I have actually input in variable t is underscore r, and this is identical to the matrix you were provided in lab 1. And what this actually represents is that this so it's like a feedback form being shared in a class, and each student can provide a rating of 1, 2, 3, 4, 5. So actually the columns represent what the rating is. I think I can also use some annotation. Yeah, so this is like a rating of 1, rating of 2, 3, 4, and 5. And the rows actually refer to the TA. So it's TA1, TA2, TA3, and TA4. And this is R. So this is rating, is the column. So actually TA1 received uh, a rating of 1 from 5 students. TA2 received a rating of 5 from 5 students. TA2 also received a rating of 3 from 12 students, and so on. So what's our first question is that we want to find the average of maximum number of students that provided a specific rating to each TA. So what this mean is actually that we want to find the uh, maximum particular score, the maximum number of students that allotted a particular score to a TA. So for TA1, it would actually be a rating of 4 provided by 28 students. So we are looking for this number 28 for TA1, and 14 for TA2, 20 for TA3, and 18 for TA4. So these are the values. This is a toy example, and we can visualize it. We can also like manually see the answers that we are looking for. So this is it, and then we want to perform its average. So average is simply like we take these four maximum numbers that we are obtaining, and then we'll actually divide it by 4, since we would be obtaining, since we are performing simple average, and we would be obtaining 4 rating. Here actually we won't be using loops at all to actually simplify things. We have already seen for loops and using only for loops in question 1 in great detail, and now we would only be using for loops where it is necessary, where we have to make a basic selection and something like that. So here where you may be actually tempted to use loops is actually you want to perhaps loop over this matrix TAR, and for each row actually select a particular number by first looping over these rows, and secondly looping over these elements. So it would actually be 2 loops. But to avoid that, and we are also like perhaps a bit short on time, so I would be straight ahead just using either functions or matrix multiplication. So how you may have used the max command till now is probably just a 1D array, max 1, 2, 3, and maybe you would have done something like maxwell and max int. But since MATLAB is a very mature language, it is a lot of people have worked on it. So for these kind of frequently encountered and trivial things, the operations are already present. So this max, we should suspect that it should be able to handle the uh, multi-dimensional arrays. So what I can do is, let me check if it does. So I'll just open a documentation, and here I see yes, it actually does handle multiple n-dimensional arrays and so on. So you can read up on the documentation, and I will just be providing the actual code here. So to find the maximum of TA of each TA rating, I want to do a row wise maximum, or I want to find that for each row what is the maximum in each column, and column is actually my second dimension. So what I'll do is I want to find maximum in this matrix TAR. This is just some syntax thing that I want to restrain myself to TAR, and then I want to perform the maximum in columns. For each row I want to find the maximum in columns, and let me see what it provides me with. So yes, it indeed does. So I was looking for 28 from first row, 14 from second row, 20 from third row, and 18 from last row, and it indeed provided me with it. And now I want to find like the average. So average TR is actually so max. So once again I'll be doing like this summation of the maximum, and then I would be dividing it with the number of elements in this, and this is actually TAR, and let's see what this comes out to be. Yeah, so 20, and that's fine. And here we actually used functions. You could have also found the average using simple matrix multiplications or vector multiplications, if you may. So how we would be doing that is actually, I know that for finding the, let me also like get this. So when I am finding the average of max TR, what I am actually doing is 0.25 into 28 plus 0.25 into 14 plus 0.25 into 20 plus 0.25 into 18. So I can already see that I have, if I have a vector of all 0.25s, and it's like a 1 cross 4 4 vector, and I multiply it with this column vector of 4 cross 1, I would be getting the average. And this is exactly what I would be doing. In a more generic manner, what 0.25 is, it's actually 1 over the number of elements in this column vector. So this would actually be 1 over 4, and then I would be, but I actually need a row vector of it. So this is like 1 over 4 into ones 1. Or let me just do it like, I can just call it 1 over 4 vector for now, for a lack of better word. And what is this vector? So this is a vector of all 0.25s, and I found it using this uh, generic type of commands. And what I would be doing next is to find average max TR, and using like multiplications M, and I can call this L. So this would be 1 over 4 vector multiplied by max TR. What you should note here is that max TAR is already a column vector, so I won't be doing transpose now. And I think I can close this, and what we should obtain is that, all right, so I think I can remove this annotation. Yeah, so I removed all the annotations earlier. Yeah, so the average through both the methods actually end up being same as we expect. And here we have performed matrix multiplication. We could have taken this thing above 2 for a one liner as well, but this actually makes it more interpretable. And the next thing is, what is the average rating each TA received, and how would we be computing that is based on actual scores is, so this is the row for TA1. So the average rating actually TA1 received is actually 1 multiplied by 5 plus 2 multiplied by 10 plus 3 multiplied by 15 plus 4 multiplied by 28 plus 5 multiplied by 2, and then we would be dividing it not by 5 actually, but by the number of ratings it received. So that would actually be the sum of all this of this complete row. So let me like initialize a rating vector. So this is just 1 2 3 4 5, and instead of doing like this, so I would be looping over this tar t underscore r matrix, and I would actually be using these 4 indices, and rather than doing this again and again, tar and 1, what I can do is to make it more interpretable and readable. I can do that num tas is equal to this, what is average ta rating using functions. So let me just make a placeholder of sort. So one num tas, and it would be once again same for the average TA rating, which I would be finding through matrix multiplications. As already elaborated so far, like T is just the index of the TA. So 1 to num TS. So for each of them, what I want to do is, so for a particular TAI, the average TA rating is actually the element wise product of this rating vector and this TA1 vector, which is what we actually discussed in plain terms earlier. So it would be an element wise product of R. For element wise product, we add this additional dot here into TAR, and I'm using actually index T instead of I. So this is what we do. Then we actually sum them up. So I sum them up, and now I also want to take its average and average over the number of students. So I also want to sum this up. So this would be 1 over the total number of students is sum this sum is complete, yes. And now let me check what average TRF is. Yeah, all right. So the first TA received an average rating of 3.2, other one received 2.6, then 2.96, then 2.85, and so on. And we could have also implemented it without these sum commands using just simple matrix or vector multiplications that you may now be familiar with. So what we do is that for this part, this is like a part very similar to what we did earlier. So we can just, that this is the multiplication and no dot here. So multiplication of R with this row, Tth row. If T is 3, it would be R multiplied by this. And actually it's, this is a row vector. So I'll have to do this. All right. And now I want to take its average. So this right part is equal to this thing. And now I want to take average. So I'll have to like divide it by 1 over. And now I want to do is I want to sum 5 plus 10 plus 15, 28 to, but I don't want to use the, what can I say, that I don't want to use the sum command. So I'll just create a vector of 1. So it's the sum is actually 1 into 5 plus 1 into 10 plus 1 into 15. So it's a vector of ones of shape 1 and numTar. All right. So, and I want to multiply it with this. Uh, or let me just actually break it down into two lines. So I'll say one's vec is, or I can call it like sum vec. So num students. Num students is actually 1 multiplied by, so the summation of all these, and we can perform this summation in terms of this, and I can now do num students. Yeah, this looks actually neater. And did I make an error here? R multiplied by, all right, yeah, this appears all right, and I can, let's see what we get. Yes, so we have received the same ratings, first from using functions, using sum as well as element wise multiplication, and in other case we actually just perform matrix multiplications to obtain the same result. And had we used for loops here, it would have become more messy code, more likely to make a unintentional error there. But this is actually neat, and we have actually performed the same computation through two ways. If you are comfortable with vector multiplication, then this is great. If you are not so comfortable with matrix multiplication, you can continue using these sum functions, max functions, and things like that. And typically actually matrix multiplication would primarily be able to actually replace some functions, but for say a max function over a over an array or something of that sort, then you would actually be constrained to use the sum or the actual function like max. So here we did not replace a max with the vector multiplication because that is not possible. And this concludes my tutorial. I hope you actually ended up with a good interpretation of what loops are, and that while loops are an amazing thing, and it can and it should actually be used to replace redundant repetitive tasks to make things simpler, sometimes or it is recommended that when you're actually performing some arithmetic operations or stuff like that, you actually replace tedious loops like this, which would be used to make to perform a dot product, with something much simpler like this. And for that we also propose two things. Vector multiplication is great. A lot of electrical engineers, mathematicians, they would actually prefer this. But MATLAB also provides you with a functionality of using well-developed commands like sum, maximum, and things like that to operate on a multi-dimensional array. And then we actually discussed another problem which actually stems from a problem that you already saw in lab 1, and through that we obtained we actually answered our questions in a very neat way. And this is what was already provided. So in just like 4 lines, and in these 4 lines we have actually obtained the solution through two different methods. So on average in just 2 lines we were able to solve this. And then once again in 3 lines, say, or the 3 to 4 lines, we obtained the average rating each year received. And what is important is that in this toy example, our dimensions are very manageable. You can possibly also provide these answers in a rather quick manner in by performing it manually. But in practical cases, when we would be having these matrices, they are often very large, of dimensions of the order of 6 or even beyond. Even in your current lab task, you have already seen matrices of size 40,000 and things like that. And there it makes a lot of sense to form this generic sort of formulation, make use of matrix multiplication or inbuilt functions of MATLAB to actually perform fast computations. We hope you actually learn from this tutorial and this helps you in completing your labs. So this would be the end of it. Thank you.